I'm part of the people and talent circle within Consensus. I help global campus recruitment for us from a worldwide standpoint, as well as I do some sales for some of our different startups and spokes that work among our Ethereum platforms. So Consensus is one of the world's largest Ethereum application platforms. We have our Consensus Enterprise that handles a lot of different duties within our blockchain, as well as we have 45 different startups that work in a numerous amount of different entities to help do what we do on a daily basis. So pretty much we wanted to sponsor all of the blockchain events. We're sponsoring this one. We're sponsoring Blockchain for Social Impact, as well as the Philadelphia Blockchain Meetup as well. So if you guys are looking to start another meetup event here in town, or you're looking to become more oriented with blockchain and consensus in any way possible, reach out to me. My email is mike.mccoy@consensus.net. That's mike.mccoy@consensus.net. MCCOY, pretty simple. Thanks guys for coming out. Hope you have a good time.
All right, now time to introduce our speaker, Ryan. He came down from New York today to present on foam protocol. And I met him in Denver. He was giving an awesome presentation out there to Ethereum Denver Meetup. So we had to have him here. Luckily he agreed, and here he is, Ryan King.
Thanks everyone for coming. So I'm going to present about Foam, which is a geospatial protocol built on the Ethereum blockchain. I'm going to walk through the different parts of it. So there's actually like three main elements to Foam, what we're working on. And the first is an open coordinate protocol. So I mean a geolocation protocol for smart contracts to use. And then we're working on a validation system. So how can you validate and prove things that happened in the built environment on the blockchain? And the third thing we're working on is a web app called the Spatial Index. And this is kind of a general purpose block explorer to visualize spatial smart contracts. So I'm going to walk through those and then do a demo of this app, and I'm happy to take any questions. Okay, so starting with this open coordinate protocol. So we keep hearing how blockchains are going to eat the world. They're supposed to take over every industry and affect things from real estate to supply chains to augmented reality. However, there is no way that's standardized for smart contracts to reference the built environment. So with Foam, we want to add an entire new layer to the Ethereum stack, which is a location layer standard. And you might think that a lot of people think geolocation is a solved problem, but there's actually many different types of location encoding standards. Some you're probably very familiar with, like postal codes or latitude and longitude. There's also some funny ones called like what 3 words that can take any 3 square meter on the earth, like the middle of a desert or a park, and give it 3 words. So there's a lot of these location standards that are trying to be human memorable and down to very specific in a way that a street address can't be. And when you look at a lot of these different smart contracts from like drones or IoT, one uses latitude and longitude, one uses a physical street address. So blockchains, which are supposed to be interoperable, when they start try to reference the built environment, suddenly aren't. So what we came up with is something called a crypto-spatial coordinate. And this is taking an existing location encoding standard called a geohash, which can take anything up to a 1 square meter or not and give it a very short address. And we provide a way for any smart contract address to make a claim to a geohash, and out of that get a unique identifier called a crypto-spatial coordinate. And we started working on this, and this is not anything driven by a token, and it's not even necessarily Foam specific, but we see this as a standard that any smart contract could utilize, whether it's in the supply chain or IoT, as a way to get an address in the real world. And you'll see further in the presentation of why this is important, because we want a way to index contracts spatially, track them spatially, and basically understand these new economies on the blockchain that relate to the built environment. And so we see this coordinate protocol as introducing a new spatial dimension to the blockchain, and it allows multiple claims to the same location. So what I mean by index spaces, you can have a video game making a location to Times Square. You can also have a real estate use case making a claim to Times Square, and you can have your mom making up her own token at Times Square. And they can all be indexed accordingly and get their own subaddress, but basically be able to speak across verticals about the built environment. And we saw this as a really important starting point to propose a standard for geolocation within smart contracts. So that is our crypto-spatial coordinate protocol. And so any place can get a unique identifier, which is this crypto-spatial coordinate. We call it a CSC, and you can see it comes out to basically an address like that. that's mathematically determinable. So you could look up different contracts by these addresses spatially, and all different kind of locations can now start to get these addresses that are the same, or at least can communicate to each other about them. Okay, so the next thing to build on top of that is then a validation protocol. So, sure.
Are these two-dimensional or three-dimensional?
Yeah, so the coordinate system is just two-dimensional. You can layer in 3D stuff for different use cases, but this is just a tool for smart contracts to reference the two-dimensional plane. And then we're working on this validation protocol. So you have a way for smart contracts to reference the built environment, but you have a way to prove things actually happen there. So was this ship actually at the port along the supply chain? Did these checkpoints happen when I said they did? Or was I actually at this restaurant to claim my reward tokens for some loyalty reward points? So a range of different things that you can think of, what did this actually happen? And so we call this proof of location. You can think Bitcoin does something called proof of work. Ethereum is proof of work, and they're trying to move towards proof of stake. Different protocols like Filecoin for storage have proof of space, meaning storage space. So here we're working on something called proof of location. And something about all these decentralized protocols you can think of that they all basically hire people. Bitcoin hired miners worldwide to get to work for them. And with the new Ethereum protocol, they're trying to hire stakers, people to put up capital and stake. So here we want to incentivize people to verify location information. And so what does that really mean? So with a proof of location, we want to be able to come to consensus on whether an event or an agent has verifiably been at a certain point in time and space. And we're going to be doing this through a system of synchronized clocks and triangulation to determine geolocation. Also by utilizing a new paradigm in low power wide area networks, which I'll get into. And we want to have this entire system be driven by cryptoeconomics and incentivized proofs. And so when trying to figure out like proof of location or geolocation, it actually has a lot in common with time synchronization. Because if you can receive messages from people and have a timestamp and measure that against how long it took for you to get it, like the laws of physics, you can start to determine distances. So we're looking at this from a kind of time synchronization protocol that can be Byzantine fault tolerant in a way that if some nodes are malicious or faulty or lying about their location or what time it is, the system can still survive. We want this geolocation protocol to be independent of GPS. GPS is a single point of failure, but also it doesn't work through buildings, indoors, underground, etc. So it might not be the best use case for billions of sensors that are indoors and outdoors. We want the system to be trustless. In a way you don't have to trust any central point of failure. And we want this to be driven by different punishments and rewards. So if I tried to cheat the system, I could be financially punished, but if I actually help the system grow and thrive, I can be financially rewarded. And so we keep hearing about IoT and all these different sensors and devices, but it turns out it's a big problem independent of blockchains of how do they actually talk to each other, but how do they talk to each other in a way that's like cheap, efficient, low power, and can also go a long distance. And so there's a new kind of development in these low power wide area networks that are very long range and have a long battery life. So we've started with this technology called LoRa. It's a chip, may become a standard, maybe not. We're agnostic to what becomes a standard, but it can go about 10 miles at the radio frequency and have a battery that lasts 10 years. So this is this LoRa chip and standard, which is what we've started experimenting with this proof of location protocol. And just for illustrative purposes, basically in this protocol, we have this idea of zones and zone anchors. So you have a physical beacon. You need 3 of them to set up a zone, and they can start speaking to each other about what time it is and how far apart they are. And then they can be ready for entities that enter their zone and want their location verified, whether that's an autonomous car, a drone, or a person in a zone, for whatever those use cases are. Sorry, what?
Who would provide these beacons?
Users are incentivized to set them up in the same way you're incentivized to mine Bitcoin or Ethereum. So that basically, if you have those beacons set up, they can triangulate and then maintain a zone and a quorum about what's happening there and be able to validate things that enter it. So that, and if this network started to grow across the city, you'd start to get these extended zones that then can be maintained and validate location for whatever use case basically that wants to use it. And so this aspect of Foam is driven by a token in the same way it's a staking protocol. So to be able to be a validator, you have to put something up at stake. And if you basically are malicious or you lie, your stake could be slashed. But if you just participate and behave correctly, you could gain rewards by just having passive income for people basically paying you to validate their location. So that's the proof of location protocol. And then the third aspect of what we're working on is the Spatial Index web app. And so this is basically a way, we have with the Open Coordinate Protocol a way to basically give a physical address to smart contracts. With our proof of location protocol, we have a way to validate, is that thing actually there or is it not? With the Spatial Index app, this is a way to actually visually interact with all that information. So we see this as kind of a cross between a Bloomberg terminal and Google Maps in a way that it's spatial, it's visual, it's like a map, but the information being displayed to you is from the blockchain, so you can visualize these new markets. Probably hard to see this diagram, but we have this kind of custom architecture for this app where it's all run in the browser, but can still talk to the blockchain. So we're building with this Mapbox company and basically a WebGL map, and you can log in with MetaMask and push to the blockchain. But then we built this custom backend database and an API in Haskell, and that can feed the front end, and we've made a custom library in this formal functional programming language called PureScript. And so one of our lead engineers has made a PureScript Web3 Ethereum library, which we've open sourced. You can find on our GitHub. Thanks. And so this is agnostic to Form, even though what helps power our Spatial Index app. But it's basically a library connecting this PureScript language, which compiles to JavaScript, but it's a functionally strong type language, and connects it to all the Ethereum endpoints. So that's kind of what's powering our app, and then this library is available for anyone to use for anything else. So this is the Spatial Index. I'll show you a demo in a moment, but it's basically a visual explorer that you can then see any smart contract that has a crypto spatial coordinate address, so then it would be indexed accordingly. And this is also general purpose, so you could skin this for a supply chain only app, you could skin it for a Pokemon only app, or you could track everything on the blockchain. It's just an open architecture. So you could zoom in, you could inspect things there. Here is the new lab, which is our office in New York, for example. You can see its smart contract address, its crypto spatial coordinate. You can see how many tokens are tagged at that location, for example. If not, or explore the network statistics. So I'm now going to try to demo it. Okay, so here is you're basically in the Spatial Index app, and so this is running in the browser, but you can also send things to the Ethereum network. So I'll show you about that in a second. Okay, so what you're seeing here then is a simulation, but it's running on the Rinkeby test network of Ethereum, so it's live in the Ethereum app. So basically every blue dot represents a beacon that has been deployed by somebody, and the green is showing the potential triangulations that you would see form once that they can establish kind of a zone. And so basically if I wanted to add a new beacon, I would do it physically in the real world, but for the sake of the app, I can click on a location. It tells me the latitude and longitude. It tells me what the geohash is. I can name this beacon Philly that I want to put there. My MetaMask pops up. I can put a lot of gas there so it shows up quickly, and basically submit that to the blockchain. And then when you open MetaMask, I can see my recent transactions. So here I open this up on the Rinkeby testnet, and I can see that this transaction is now pending. But basically, once this block confirms, that beacon I just deployed, which now lives on the blockchain, will also show up in the Spatial Index in this WebGL app, so that you can basically get information fed to you from the blockchain in this app, and you can also add new information to it. So let's see if that still hasn't gone through. It takes up to like 40 seconds on the testnet. But while we're waiting for that, the next quick demo is that we have a simulation then of Uber data. So this is live, mock Uber data from Uber, and you can see the orange is these cars driving around. And if we turn on basically potentially hard to see. But if you see any of these red lines popping up, that's the Uber cars driving through the zone so that they could basically have their location be tracked while they're in the zone. We're playing with that then being state channel based so that they can ping all these beacons at once, and once they exit, they could publish to the blockchain their location. And so as we continue to build out the physical prototypes of the beacons, they will actually be out in the real world, and then they'll continue to show up on this map. And then the architecture for the spatial index will also be open source, so people can build their own spatial applications for any use case that they want on Ethereum and leverage basically these tools. And basically, it's a little slow, but you can then basically explore the whole map and anything that shows up there. In this case, it's a beacon. In a different use case, could be something else. The point is you can basically add things to the blockchain. This one is now confirmed, and they would show up on the map. So that's our spatial index application. And just in conclusion, so we basically, all the things we're working on with Foam as an open location standard, we see has a vast field of applications. So as I mentioned, we see this applying to blockchain use cases on the Internet of Things. We're working on potential pilot projects in supply chain, because supply chain needs to know about the who, the what, the why, and the how, but a lot of those use cases right now are missing the where, so we can be this kind of standard for them to be able to add geolocation to supply chain use cases. Geospatial data can be tagged to locations on this real estate and land ownership, so whether you have a land registry in Sweden or one in Dubai, they can each be different and have different jurisdictional rules on the app side, but underneath on the protocol, they're using the same spatial standards to reference the built environment. And as I mentioned again, could also be different kind of video games, augmented reality, spatial ones can be tied to the blockchain and be indexed spatially with our protocol. So I'm the founder and CEO of Foam. My other co-founder, Katya, who's here, she's our chief creative officer, and our CTO, his name is Christopher. And just a quick background about us, this is our office in the Brooklyn Navy Yard. We work at the place called the New Lab. It's basically an urban tech hub in a refurbished battleship warehouse. They used to build ships there from World War II and World War I. It's now been turned into a tech hub. So this is our office where we're doing these kind of experimentations. And yeah, we basically see Foam as a crucial Web3 infrastructure for blockchains and Ethereum as things more and more want to break out of just being software-based, like prediction markets, betting, or trading. Once they start to bleed into the real world, they're going to need to have a standard to basically add geolocation to smart contracts. So that's it, all I have. Thank you, everyone. If you want to join our Slack to learn more, happy to take any questions or have a conversation.
Yeah, thanks. That was incredible. So my question is really about the beacon. So you guys are testing a particular chip, but I'm assuming that it's going to be independent of any particular chip, right? Because Sigfox has theirs,
Yeah.
Comcast has Machine Q. All of them have different. So it will not be relying on any particular chip technology.
It remains to be seen. We're starting with the LoRa one because it's open source and there's a lot of open source libraries for it already and a lot of big industry players backing it, like Cisco.
Right.
But yeah, we're agnostic to see what becomes the standard, and then whichever will be the most prevalent in cities, basically.
Right. So if there are multiple Internet of Things networks and chips, then I guess you guys could adapt them maybe. So
Yeah, or there could be different hierarchies of security where some are Bluetooth based, some are this, but then so we're still trying to figure that part out.
Did I get right that the beacons are effective miners?
Yeah, I'm not so comfortable using the terminology miner here, but yeah.
That was the analogy, I think.
Yeah.
Everyone has a miner of some sort, right? Space.
Yeah, we basically want to hire
This
people
is-
that set them
I
up.
could invest in 10 beacons, put them 10 places in the bridge that have to apply, essentially.
Yeah, and then you would have to put something up at stake to join that network. So if you tried to attack it or be faulty, you would be able to be held accountable financially. But otherwise, if you're not acting faulty, you're incentivized. So this tech already exists. You can set up your own mesh net with this radio technology, but there's no incentive for people to actually set up as many as you saw in the demo. So, and then for all these different like self-driving cars, all these different standards are going into being proprietary and into single sources, and we can't really have that. We need to share resources about that, especially with like robotic cars driving around.
You mentioned the incentive programs that are making. Can you talk a little bit more about the mechanics of that and whether actually getting used for recycling?
Yeah, so I mean, that's the main area under development of the actual crypto economics of the protocol in terms of like number of rewards. But the idea would be you have to pay some sort of entry costs, and you have also then an existence cost. So whatever you paid is locked up there. And when you first joined, you'd be sending out some sort of sync message. And if somebody answered you, if there was a zone already there, you'd be able to join it by synchronizing your clock with it. Or if you were the only one around, you would just be sending out basically a call for people to join you. But once 3 at least joined, you can then establish a zone, and your zone would be active on the network, and then you would just be there all the time waiting for someone to pay you guys to have their location verified. Then we're thinking of different ways about that money being in escrow and those fraud proofs being published and having some extra third party that's not the physical beacon, do some sort of race or check, which might be similar to some sort of proof of work. And then only then would the money move, and then the beacons would get paid then. So we're still kind of working through those parts. We have the most developed, the coordinate standard and the web app, so those are kind of the harder problems on the protocol.
But running a beacon, you're going to only get money when people need a location within your zone.
Correct, but
The incentive is to go where the population is, or at least for the center population.
yeah, or who knows how to develop. Maybe in rarer places, the cost is higher to every location. Yeah, maybe not. But in sort of like ports, you could have different buoys with beacons and be able to track and telemetry follow things that way. Yeah.
So that makes me wonder, do you have to hold a physical space if you're hosting a chip, or can anybody go in and start planting these inside walls or whatever? It just seems like if you only need 3 to have a triangulation, you only need 3 to have forums, you need anybody to scoop the system and blanket an area so that it's like clear chips are, you know, the truthful ones when you're trying to actually scoop the system.
Yeah, so that's spoofing is the main thing we're trying to stop against, which is like this fault tolerance. And that's part of the reason why you have to stake in the first place. You have to put up capital. So if you're trying to basically Sybil attack or put up thousands of nodes, there's a cost attached to that. But basically just 3 is not really that powerful. So like the denser the network becomes, the more active it can be. And no, you don't need to own the space, because the reason these kind of low power wide area networks are so interesting compared to GPS is they actually work through, they're really great in urban environments, and they walk through walls and ceilings and doors. So if you just put it on your desk in your office, you don't have to own it, it can still be part of the network.
Why not just use like regular 211 protocols and Wi-Fi? I can walk through Philadelphia and always pretty much have some Wi-Fi connection. My phone's already got it, and all other devices can support Wi-Fi to some extent. There's plenty of broadcasting needs. You just sit on top of that, and then the device itself has the code running on it that wants to then do all the triangulation, basically.
Yeah, I mean, for us, I think the Wi-Fi is just about the distance, so there's such short range, but there are basically location protocols for Wi-Fi and Bluetooth as well, so we're exploring, basically even potentially supporting more than one type of radio band. So you have like short range, medium range, and long range per location. Yeah.
But you're just but you're stuck then having the receiver also be compliant with that band.
Yeah. I mean, the interesting part about LoRa, it's an unregulated band, so you don't need any sort of special license. But yeah, it would be contingent on every device having it, so that's why we're just testing it first with that one, because it's off the shelf and available, and we'll see what becomes a standard over the years.
What's the strength of a beacon? Is there a predetermined size?
Just generally, I mean, it depends on line of sight, but they're supposedly can go up to 10 miles.
I don't know much about LoRa or the type of networking that you're describing, but you said that this isn't it hasn't proliferated too much yet. If you're able to properly incentivize the economics to make these LoRa devices kind of proliferated in major cities, what other benefits can citizens get just in general, just from there being LoRa devices all over the city, like beyond just verifying locations? It seems like you'd be enabling functionality that isn't possible today.
Yeah, and I mean, that's something we're most excited about. So foam is really on the protocol level, but we imagine many different, and it's not rent seeking, so meaning there's no like fee we're charging to use our protocol. So the idea would be that many different, hopefully imaginative applications can be built on top, some with profit models, but then it can really have the citizens be really creative to come up with different geospatial games. We saw how popular Pokemon Go was, but it was a flash in the pan, but you can develop different basically advertising incentive rewards, like weird augmented games. Like Snapchat glasses were insanely popular because they were hidden spatially. So once you can prove people's location, you can make very interesting games or different even ad campaigns, and then people wouldn't be able to cheat because they'd have to prove their location all the time or something.
Is it possible to communicate through these networks when like the internet goes down? So if there's no internet, is it possible if they were distributed all over Manhattan?
Yeah, so that they don't necessarily use the internet. They're synchronizing just over the radio waves, and there would need to be a gateway node basically. But in the case that it went down and they were pinging all the time, they potentially were on state channels. So then they just wait till they get network connectivity to publish it to the blockchain.
But with the internet down completely, I'm just talking about LoRa technology.
Yeah.
Are you able to send messages across the city without any internet?
Yeah, up to 10 miles. Yeah.
So CSCs, they're unique to locations, not to contracts.
They're unique to contracts. So the geohash is unique to a location, and it's like a nested property. So like this building has a geohash, and some square meter inside can have a geohash that's related to that one. We allow any unique smart contract, because everyone is different, to make a claim to a geohash and get a unique CSC. So that means like many different contracts can claim the same location, and then they all get a unique identifier. So then you could start to index and stack. And on the viewer side, you can say like only show me things with a certain amount of balance, because that means they're more legitimate versus spam or something like that. So a lot on the client or user experience side can also define how you filter out spam versus valuable information.
So the CSC in a sense becomes an identifier for the contracts that are...
Yeah, a spatial identifier. So we use that then to index everything and visualize it. Yeah.
So if I understand it, the more beacons you're able to reach, the higher the integrity.
For the, yeah.
Okay. What do you see right now as killer apps?
So we're talking with like car companies who are interested in like proof of mobility, or if they have basically real-time mapping and real-time fleets of cars speaking with each other, they want a way to be able to communicate about where they are and the conditions in the built environment, but in a way that's fault tolerant. So not one single company necessarily needs to control the system. And if cars were breaking down or lying maliciously or on accident, the system was able to be self-stabilized. So looking at car companies, but then also just different IoT devices, talking with companies that make...
Cars already have their own.
Yeah, they have a V2V system. There's a broadband sectioned off by the FCC to allow for that, but there's very little work done there, even in the automotive industries. So something like the Toyota Research Institute, they're like working a lot in Ethereum and like very interested in branching out into these kind of protocols.
Are you working with Toyota?
Not formally, but talking with them. Yeah.
So we're getting into the area of applications versus protocols. So can you explain the difference between protocol tokens and app points, and why innovating on this level is different in the blockchain space?
Sure. Basically, well, you see a lot of different app coins today, and it's kind of nebulous to understand if you actually needed their own token or they just used it as a fundraising tool. We see basically a protocol being something that's free and modular and something that people can hook into and build on top of. So basically apps don't usually have those properties because they're kind of self-contained. And whether or not they have a token, that's kind of up to them. But we see why we have a token is because this is an independent system that you want to have separate from the monetary policies of Ethereum, so it's not tied to the price fluctuations. And that basically you can then design your own crypto economy around this one use case. But then our token is an Ethereum token, but it's on the protocol level, meaning that it's like designed to be hooked into and integrated with other things. So you could then have an app that's using Foam, but it's also using Uport for identity or Filecoin for data storage, and Foam is just one of the many protocols in the app at that level. I think app tokens, I don't have that much to say. They could be good, they could be bad.
What's your roadmap like when you're planning to go live?
Yeah, so we're by the end of the year planning to release a new white paper outlining the proof of location specification with like a new website, like a promotional video and more material, and we're planning a token sale for Q1 of 2018.
Talk to DARPA.
DARPA? I haven't. No. Okay, sure.
Any other questions, guys?
Could the beacons move around? Do they have to be in static locations?
Yes, they can, but in our vocabulary, like the zone anchor, the one that's like maintaining that, for at least now, it would be static. But then the things moving in and out could still be called beacons, but yeah, so there's like a differentiation. But the ones static maintaining the zone are like the validators and the ones staking.
Just curious, how long have you been working on this?
2.5 years as foam, but not on proof of location. So we started as actually architects, like building real buildings, experimenting with kind of cultural institutions in New York City. So we won like a competition with the New Museum and the Storefront for Art and Architecture, and worked with like Guggenheim Museum, where we built temporary installations and gave out tokens to people who came to try to like capture spatial value. And we did a different installation called the Tropical Mining Station, where we had a big inflatable bubble you could go inside, and the Ethereum miners were on the outside, so all the heat was getting captured, so you could like make money and also get a free heated bubble. So we were basically started experimenting as architects with how can you use blockchain in space in the built environment, and it kind of morphed into what we see today.
And it's just 3 people.
No, we have about a team of 10,
Oh, okay.
3 co-founders.
What's the business model that allows you to do?
So we're opening a nonprofit foundation, and the business model, there is no business model. It's not rent-seeking, and there's no revenue. And the foundation, will be nonprofit and be there to kind of oversee the development of the protocol, make developer grants or investments in other applications, and bring together kind of cryptographers, cartographers, industry leaders, and oversee that. And then different entities, including our own company, could make for-profit applications then.
How will the foundation get revenue?
Through the token sale.
You keep saying built environment. This is not this, but I don't know.
Just the physical world versus like cyberspace.
I don't want to focus, I know you're not working on cryptoeconomics, but I'm thinking about some of the use cases I'm encountering, like delivering nonprofit, remote areas, it kind of combines insurance, where you have validators of actions that are connected in, so you would need to validate location, time, with other photographs, things like that, insurance apps, insurance, so I'm just thinking, there's no cost. There's no cost to use trading the token. There's no cost to it. Cost is all run relatively smart contract.
I mean, if you want your location verified, there might be a cost, but the money would go to a validator, not to the Foam Foundation.
That's what drives the value.
Yeah, and then if many people are.
So there's a cost, but it's purely internal between suppliers and.
Yeah, there's no rent seeking on us, or we don't take any. And you see some.
I got it. But the validator is paying to buy into the system.
Initially, but the idea would be they would get a return on their investment. And the same, if you're familiar for the trajectory of Ethereum, it's currently proof of work, and they're transitioning to a proof of stake, meaning they wouldn't waste energy mining. You would instead stake your coins to the network and run as a validator. And so we're kind of building off that research and applying this kind of logic to a different protocol.
So if I like on a chip and want to add it to the network, it looks like I would go in and self-report where exactly I was putting that chip on an app. Like, how do you guys validate the accuracy of where it's
There's a few different ways. I mean, you could use a GPS signal in your device just to get where your location is, and then from there, once the other beacons start to talk to you, they would be able to know if that was accurate or not. You could self-report. Maybe there's a window of time for you to edit it before you started to get punished. Where you need to kind of build out the physical system to learn its limitations to then get into how that's going to work.
So what I'm hearing is that there's 2 hardware components. There's the beacons that are tracking things, and then the signal that's being emitted from the self-driving car or whatever that is being from that beacon. Right? Are these the same hardware? You have to have a chip installed in each car.
Well, we imagine as Internet of Things or all these things take off, something will become the standard. So we're open to whatever it will be. So we're just working with this one now because it's really easy to work with, but could be 5G comes. We're just we don't know how the with or without a blockchain, the car is going to have to talk to a beacon. So there'll be something that's standardized eventually.
I heard you say state channels. Is that the plan going forward for how to scale up?
It's a scaling solution that's complementary to other ones in Ethereum, which basically means if you have a lot of active transactions, you can do them off the blockchain, but you always have like a receipt. And so if the other person tried to like cheat, you could publish your receipt to the blockchain so that you could do like thousands of transactions without spending any money to publish it to the blockchain and publish them at once. So in our case, if you had a car pinging every beacon through the city, they wouldn't have to pay gas fees to the Ethereum network. For all those pings, they could just do it at the end of their route or something.
And that's the plan that you're going after?
Yeah, we're working on implementing state channels now.
I have two questions. First, is there anyone else doing anything similar? And second, if I were to buy tokens in your token sale, would that benefit me in some way? In other words, I'm going to trade it later for what would I want for tokens?
Well, it's a utility token, so it's tradable, so of course you can trade it if you want, but it's meant to, if you want to participate in the network.
As a staker?
As a staker, but I guess I didn't get into it here. Same with this Ethereum staking, there's like a staking maximum, so they're only allowing 15% or 10% of the total tokens to be validating, and so there will be something similar where then the rest of the foam tokens, there's going to be all these different use cases and apps that are spatial, involve going to a beacon and interacting with it, so you can then use the token for all these different apps or use cases that would be developed. So we're interested, like, if you're near a beacon and it's maybe through Bluetooth or Wi-Fi, I can unlock a certain feature or get a token or trade mine if I'm near it. So ideally, you'd be able to use it in many foam apps other than just being a validator.
Is there other people working on a similar idea?
Not really. There's a few people working with things that are spatial, so like a drone one or IoT one or this one, and we're in touch with almost all of them. Nobody's really talking on the core protocol, like we need a location standard. The CSC standard we eventually want to work and propose as an EIP, which is an Ethereum improvement proposal, so that actually can be standardized. And we're just really doing that to increase interoperability to make sure all these contracts can still speak to each other about space in this case.
Is the token sale the only token fusion event?
No, so we're actually planning to sell about 30% of the total supply and another 20% to be available once the network is live, so that the rest of tokens are distributed by participating in the actual network or validating things, so that you'd be able to earn or buy tokens once the network is live. Any other questions?
All right, thank you so much, Ryan. That was so interesting. How about another round of applause?